My name is Marcos Garcia Costa. I'm with Intel Corporation, and today we are at Carl Hayden High School here in Phoenix, Arizona. We're at the robotics lab where they work throughout the year on different robotics programs that have allowed them to go to different competitions and earn a lot of awards and recognition.
Just like in the real world, the National Underwater Robotics Challenge is designed to test robots and push them to their maximum limit. Imagine you receive a distress call from a research vessel, and when you arrive, you find out you have a half an hour to rescue an ROV from the bottom of the ocean. There's one thing that may give Carl Hayden an advantage, and it's the secret weapon of the 3D vision system. And this will allow the team to be able to see things underwater with a greater depth perception and hopefully give Carl Hayden an advantage.
When you bounce polarization off another mirror, it gets reversed, just like the image does. So what we're going to do is we're mounting one monitor on top like this and another one just like this, so they're at right angles. And then there's going to be the teleprompter mirror, which is a 50% mirror. 50% gets reflected, 50% goes right through. Using polarized glasses, the way one glass will be polarized vertically, one will be horizontal. So one eye is going to be looking at the rear monitor and one eye is going to be looking at the above monitor.
We needed a strong processor, so we chose the best quad-core processor that we could find. We chose one of Intel's processors. We're grabbing in 2 streams of high def at 800 megabits per second, and we needed a high-end processor to accommodate for that, so we weren't catching any lag with the playback of the video.
In driving robots in the past underwater, everything's two-dimensional, and a lot of times we can't tell if we're going to grab something because you can do this experiment with your hand, hold your finger out, close one eye, and decide when you think you might be able to grab it. It's kind of the same thing with the robots, and a lot of times robots end up to making sure they run into stuff and then they know they can grab it. But we want to be more accurate than that. We don't want to waste time, and we want to be more delicate and not smash around. So we thought that if we can have this 3D system, vision system with the robot, we'd be able to tell, just like you can with the human eyes, both working in tandem, that you know when you're able to grab something. So we did a preliminary test, put the system together in a prototype, and the picture was phenomenal. The best 3D we ever saw.
The 3D vision system was working great. We were able to successfully grab some core samples and some bioluminescent glow sticks.
Saying that Intel was at our event, definitely going to help bring more people in, get more states involved, because people like this love Intel and they want to see more of it.
Going into the mission, we had some issues with the robots, and on our main drive robot that was a little more capable than the Stereo 3D one. It had some lithium polymer battery issues where they weren't holding a charge anymore, so we had to kind of not drive vertical and horizontal simultaneously, like go up, stop, okay, go forward, stop, otherwise our video signal loses drops below 9 volts and cuts out, so we had to be careful with that. There were a couple times where the kids were, telling each other to do stuff, and one would say, okay, go up, and says, I am going up, and you can see they're not, so there's a little bit of that tension, frustration going on.
I know what you're telling us. The robot is not responding.
Why don't you tell me that when I ask you? All right, pull up by the tether.
Really, really stressed. I kind of wanted to walk out sometimes, but I hold on because my teacher always tells me to just keep going and never give up, and that's what I did, so I just stuck to it.
So a couple times I had to pull the robot by the tether, and that gets us deduction points, 5 points for every tether pull. and I think we have a total of 10. But it's good.
Our kids are really good at working out real-world problems out under pressure. The team did as well as they could under the circumstances, and it's still probably better than most of the competition here. And so we're really excited about that. I'm pleased with it.